Welcome back, everyone. I hope that you're all set to begin the very first session. I have provided for you on this presentation uh, the PowerPoint that I will be reading from and speaking from. And if you haven't done so, you could always go to your task list on session one and print out the entire PowerPoint presentation so you have a hard copy that you could mark up. If you haven't done that, it might actually help you out. So go ahead and grab that hard copy and bring it back to the presentation. And for those of you who are ready to start, let's go ahead. I'm going to go ahead and put my picture on freeze so I can actually talk and look at the PowerPoint presentation with you. So here. All right, we are set to go. And in talking about an introduction to applied behavior analysis, it might be good to kind of talk a little bit about how, in fact, the science has been described. So if you turn to the very first slide here, the first terms that were used to describe our science was something called behavior modification. Now, back in the 60s and 70s, the term behavior modification was used just about everywhere. And literally, we say behavior modification refers to simply behavior change. When we modify somebody's behavior, we change somebody's behavior. And as such, there's really nothing quite remarkable in doing this. Just about anybody could do this. Certainly, little children as young as 3 or 4 months old will engage in behaviors that will certainly change their parents' behavior. And of course, parents will engage in behaviors that will change their children's behaviors. Many of the time that this happens, there's very little science applied to this. This just simply happens in the course of human-to-human interactions. And certainly there's nothing scientific about that. On the other hand, when we talk about a science of behavior, what we're really talking about is a descriptive science that is based on the tenets of scientific methodology applied to the study of behavior of individuals. And one thing that will become apparent both in this session and the sessions that follow is that we are going to follow the same kind of path that the natural sciences followed in terms of how they approach their subject matter, and more in particular, how they actually come to measure and assess their subject matter. Now, I want to point out again that the science of behavior, like these other natural sciences, are descriptive sciences. That is, they set up the methodology to study their subject matter, and they set out to describe the facts as they see them, what they did, what the results were, and after those results, what future direction further research might go into relative to this subject. In other words, we're not talking about an explanatory science. We don't really have a situation in the other sciences where we explain anything so much as we describe nature as closely as possible. This comes close to what we call the notion of determinism, which actually helps us in terms of going forward with scientific analysis of our subject. Now, out of this science of behavior comes something called behaviorism. Now, that's something you'll hear from time to time. It is the philosophy of the science of behavior. And there isn't really one form of behaviorism. There are actually multiple forms of behaviorism that have come up over the years depending on the type of research that was done. And we'll talk about some of these when we talk about, for example, Pavlovian behaviorism or Watsonian behaviorism. And we'll also talk about methodological behaviorism and radical or thoroughgoing behaviorism, the one that was described first by B.F. Skinner. And then finally we come to applied behavior analysis, in which we are talking about the practical application of the science of behavior to problems and issues of human behavior, cultural and society issues, problems in the classroom, problems in the work setting, how we come to understand and use greater safety techniques in hospital settings, and so on. There are many, many applications of behavior analysis, and certainly you're going to be covering many of these over the next couple of classes that you take in this sequence. And of course, you will be responsible at some point in time that you'll have to read the seminal article by Bear, Wolf, and Risley, which describes the dimensions of applied behavior analysis. This is a classic paper, as well as the follow-up to that by the same authors. Now, as I mentioned, I like to present cartoons and comics every once in a while to illustrate a point. Here, what you see is an old comic that I cut out many years ago, which says, heck no, we're not crazy. Why do we look crazy? Now, obviously, what we have here is these individuals who are talking, and the bartender asked them if they look, are you crazy? And they're saying, no, we don't look crazy. Not that behavior analysts or behaviorists in general look crazy. Certainly, I don't think that they look crazy. Now, in the textbook that we are using by Pearson Cheney, we have the opportunity to actually not only read about the theoretical positions and principles of behavior analysis, but there are little pictures of some of the theorists themselves in the book. And I welcome you to look at the pictures, and you could judge for yourself whether we look crazy or not. But I have this down here for a particular reason. Behavior analysis, its terminology, and the language that behavior analysts oftentimes use to talk about behavior is somewhat foreign to most people. A lot of times I have seen situations in which I'm describing behaviors using our terminology, and people look at me like I have 3 heads, or 4 heads, or 5 heads. It sometimes gets in the way when we are talking to people when they really don't understand our language. But one of the things that I hope that you will come away with is learning that the language and the terminology in applied behavior analysis and behavior analysis in general is quite flexible. That is, when we sit down to address anybody, we really should be doing an analysis of our own verbal behavior and try to understand the conditions under which the people who are listening to us are most likely to get what we are saying. Sometimes you will find that you will have to use a language and back off of it a little bit to make it more comfortable, more palatable for the people who we're talking to. But we always want to keep our eye on the brass ring, which is always changing, and that we always want to be able to have people understand what we're saying, but always also think about shaping it, teaching them a little bit about our science, if not our very language itself. Let's talk about the characteristics of science. And these characteristics that we're about to discuss were actually first outlined by B.F. Skinner in his book Science of Human Behavior in 1953. And in it he goes through, within the first 2 chapters, describing what is science, and more in particular he describes what science is not, which essentially is people who have lab coats and slide rules and fancy technology. That is not what really makes a scientist. That might be the tools that a scientist uses, but what we're really going to try to understand science, what we're really talking about is scientific behavior. And what are the things that influence scientific behavior? In particular, if we step back and look at the growth of the natural sciences, we will note that there are certain characteristics across all of those natural sciences that these scientists have shared relative to their own research behavior. Starting with the first one, we talk about a search for order, uniformities, and lawful relations among events in nature. And here what we're really talking about is determinism. Now, you will see details in the Pearson Cheney book, which talks a little bit about this notion of determinism. But this is a idea that really has helped the sciences over the many, many years in which research has been conducted, going way, way back, long before there was a behavioral science, and all the way talking about chemistry and physics and so on. There was always a search for order, uniformities, and lawful relations in anything that was studied at its time. We take those same principles to be true when we're talking about human behavior and behavior in general. A second characteristic of persons who practice science is this idea that we need to have a disposition to deal with facts that we derive from experimental analysis rather than what somebody has said about them. One of the things that's very important in the sciences is that these facts are developed through the science and through the research, and we develop a cumulative process of understanding our subject matter. And we always want to make sure that the limelight is shining always on the facts, not the individual who was speaking the facts. We need to be able to get away from the possibility that we come to, in our culture, worship people in science, people like Newton and people like Einstein and people like Darwin and Galileo and Copernicus and all of the great scientists before us. That is, these were brilliant people who provided so much insight into their respective subjects that they were able to build a fairly strong foundation of those earlier sciences. And along comes new facts that hopefully will help add to those accumulation of previously found facts. And I bring this up, as Skinner did, because when we come to number 3 here, we need to have a willingness to accept these facts even when they're opposed to our wishes. That there is oftentimes we will discover things in nature which are contrary to the way we tend to look at things or the way culture tends to look at things. Now we're going to talk more about this later on, because as science of behavior has progressed, we have been in a position where many of the things that our science tells us really does go head to head with many of the cherished beliefs that we have in our culture and many other cultures. Now, we're not going to address these throughout the course, but you will be reading on these specific issues in B.F. Skinner's Beyond Freedom and Dignity. It is one of the actual required readings, in which that book is an expose specifically on why science is not progressing and what are some of the issues that we have to confront as a society, as a culture, and as individuals in terms of applying the science of behavior. And these are questions that just simply cannot be ignored. They do need to be addressed. But we bring this up because when we look back at the scientific behavior of individuals in the natural sciences, they too had to present facts when they were opposed to wishes, and sometimes they had to go through a great deal of scrutiny because many of the things they said were clearly objected to by people in government, people in the clergy, and so forth and so on. The next characteristic of a science is scientific honesty. And here we recognize the fact that scientists are human, and they are subject to the same contingencies that everybody else is subject to. And although we try to be honest in what we present, there are always conditions under which science may go adrift and publish things which are not necessarily honest or straightforward. And one of the things that we have in our science, as well as the other science, is the notion that we could set up experimentation to replicate and reproduce the very facts that were described by the sciences before us. And this is what actually helps to keep science honest. That is, there's an entire methodology section which describes the subjects used in the study, the apparatus, the general procedure, and so forth. And the idea here is that if we were to set up a replication condition, we should be able to show that what the sciences before us had shown, we too could actually show. This was a classic thing I remember doing when I took chemistry in high school and certainly in college. We had to do simple replications of classic studies in chemistry. For example, we might get a piece of metal, which is called an unknown metal, and we conduct a series of tests that we follow the exact order. And if we do it right and we measure the atomic weights of everything just correctly, we actually are able to define what that unknown metal is. And we could do so quite accurately because these studies have been done again and again and again. Scientific honesty allows us to be able to do something like that. And this certainly holds true in the experimental analysis of behavior and in applied behavior analysis. And certainly as you take the other courses in this sequence and you have an opportunity to read the Journal of Applied Behavior Analysis, you will see again and again references to previous studies and the current study, which describes very clearly the procedures that were conducted to derive the research results, which becomes the basis of our evidence-based science. Then finally, I save what I consider to be the best for last: a willingness to remain without an answer until a satisfactory one could be found. Now, this is one of the things that I find extremely important, because a lot of times we live in a culture in which we are pressed to provide answers to important questions when we really don't have answers to those questions. Why do we behave the way that we do? Why does that person do what they actually do? And it's tempting a lot of times to invent answers where, in fact, rather than doing the research to discover why a person behaves as they do, we commonly explain behavior using a variety of terms. And that's what we're going to talk about now. Let's first talk about the definition of behavior as we see it as behavior analysts. The first definition actually was derived from the book by Johnston and Pennypacker called Strategies and Tactics of Human Behavioral Research. And Johnston and Pennypacker described that behavior is that portion of an organism's interaction with its environment that is characterized by a detectable displacement in space through time. See, it's so long I can't even say it. Displacement in space through time of some part of the organism that results in a measurable change in at least one aspect of the environment. Now, clearly, if somebody comes up to you at a cocktail party and asks you, how do you define behavior? And you are able to say this clearly and precisely without having your tongue tied, well, first of all, congratulations, you probably haven't had anything to drink at the party. But as you come to say this, it becomes quite a mouthful. And this is the point at which, by the time you get to the third sentence here, people look at you like you have four heads. So, another way we could define behavior, perhaps less precisely, but still has a working relationship to the above definition, is that it's anything a person says or does that's observable and measurable and conforms to truth by agreement. This is something we'll talk about a little bit later. Or, if you've had about 3 or 4 margaritas and you're really stuck, you could always come down and say, well, here's the deal. If a dead person could do it, it's not behavior. It's what we used to call, back in the 60s and the 70s, the dead person test. That is, behavior can be defined as, if a dead person could do it, it's not behavior. So you could use any of these things interchangeably as you wish. When we look back in psychology and when we traditionally talk about behavior, we are oftentimes taught to interpret behavior as follows. There is usually some sort of an environmental event that takes place in our settings close to us. It gives rise to something happening to us inside of us, typically an internal event. And then that internal event eventually leads to something called behavior. Now, this is what is called the 3-term causal sequence of behavior. And although you may have variations in this particular order of things that are happening in this internal event, they all share the same similarity. Something happens outside the body, something happens inside the body, and that in turn leads to behavior. You know, there used to be a film that I saw way back in high school in the 1970s. I think it was put together by Bell Telephone, called Gateways of the Mind, or Gateways to the Mind, in which they describe a fantastic set of events in which behavior takes place. It shows a person, and this I believe was a real person, who is doing something, and they either stick their finger with a needle or pound their finger with a hammer, and you see the finger get hit, and then the camera and the entire picture switches to essentially an animation feature in which something which looks like pain, which is a stimulus in the form of a bolt of electricity, travels up the arm and into the brain, And inside the brain is certainly not the brain that we know it today to be, tissue and so forth, frontal lobes and occipital lobes. But in fact, it is a little guy who is sort of looks like Mr. Spacely from the Jetsons, and he's sitting behind this grand console with his feet up, kind of dozing on the job. And then all of a sudden, on this grand monitor in front of him, something flashes, pain. And then he magically snaps out of it and punches some things into the keyboard. And then, after punching the command sequence into the keyboard, a counter stimulus travels back down the animated arm to the finger, and then we see a picture of that original person, a real human being, pull their hand away from the object, which is the aversive, painful stimulus. That's a pretty fanciful event which describes human behavior, but this is, again, a way in which we see an environmental event gives rise to this thing happen internally and then gives rise to behavior. Let's actually explore some of the popular ways in which we've talked about this internal event, starting with astrological causes. I hear a lot of this stuff, by the way, hanging around the Boulder area. It's really hard to escape some of these kinds of discussions of human behavior, in which they talk about horoscopes and the sign of Scorpio and Aquarius and so forth. But mainly what we're looking at here is that the planetary movement and the movement of the stars in the heavens above us are what actually gives rise to human behavior. That as these things change, human behavior changes as well. Another popular explanation of behavior is to talk in terms of an internal event which might be mythological in nature. Now, when I was a kid, back in the 60s, I used to watch these wonderful adventure programs like Jason and the Argonauts, which talked about Greek mythology and the story of how Jason and the Argonauts were able to travel the high seas and capture the golden fleece and bring it back. And it really wasn't Jason, although you were led to believe it was Jason. But every once in a while, the scenes would switch to a very foggy kind of an environment, which is supposed to be the stage setting for Olympus, in which Zeus and Hera and all of the other gods are sitting around playing what looks to be some sort of an ancient game, sort of like chess for the gods. And they were the ones who were determining the course of action of Jason and all the Argonauts on the planet, which would, obviously consist of Jason and the heroine, the name escapes me, and Hercules, I think, was in the film, and so on. Again, in this situation, we have the behavior of the individual that is basically under the control of the gods up in the heavens. We could also talk about psychic causes, which might be internal events which are taking place, which shows us psychic activity. It may involve the id, the ego, and the superego, which is said to be what governs the emission of behavior as we see people behave. We could talk also about mental causes, which might lead people to think that mental causes give rise to behavior. We could also talk about conceptual causes of behavior. Here, what we might be referring to are things such as hunger, for example. If a person is watching me eat a huge meal, they may come back and say, the reason why I'm eating that meal is something called hunger, and hunger is what makes me eat. Or thirst is what makes me drink a bottle of root beer or water or something along those lines. Not necessarily talking about the physiology that's involved or some of the most important events. And some of those most important events are not necessarily the conceptual cause of this internal behavior, but environmental things that actually give rise to me engaging in eating behavior. One environmental event that clearly takes place before I eat a big meal is food deprivation. And certainly the longer I have been deprived of food, the more likely it is I will eat food. Okay? But it is not necessarily hunger that makes me eat food. It's food deprivation that gives rise to me eating more and more food. Similarly, with thirst, I may drink because I am thirsty, as people say, but usually it's environmental events. It may be the temperature, the amount of time that I've gone without drinking anything. It could be that I've just finished one of my workouts and I'm drinking. All of those things certainly give rise to changes in my physiology, but in and of itself, thirst and hunger are merely nothing more than substitute words for environmental events which take place prior to my behavior. Finally, we could talk about neural causes. And now we are not going to refer to these neural causes in the same sense that we talk about neurotransmitters and physiological and neurological activity. Let me state now that all of that stuff is very important in behavior, not as a cause of behavior per se, but neural causes of behavior really are neurological behaviors. Something we're going to talk about later on of why we make a distinction that a neural event must cause the external behavior rather than being closely tied to the behavior itself. But what I'm really referring to here is not really the physiological neural causes, but what happens in our culture when they use neural activity in lay terms to describe human behavior. For example, a person says to a parent, why can't your son do well in school? And a parent may say something like, well, he really doesn't have the brains to be in an advanced class. Well, that's not really necessarily true. A person does have brains. In the same way, a person says, why don't you get up there and just speak from your heart or speak your mind? A person may say, because, well, I'd like to speak my mind, but I just don't have the guts to do it. My heart is not in it. This is what I'm talking about when we actually say things using neural terminology as explanations of behavior, when in fact they're really not explanations. If we actually see somebody yelling at somebody and we ask that person, why are you yelling at that person? And they say, because he or she is getting on my nerves. Are we to take that literally? I mean, is that person really jumping up and down on that person's dendrites and causing problems? I don't think so. The problem with using these kinds of terms, neural terms, as well as many of these other terms, is simply that they interfere with us looking for the real causes of behavior. And the real causes of behavior are not to be found in describing this internal event. It's actually to be found in the environment which gives rise to not only physiological changes, but also gives rise to the behavior that we end up seeing. Let me go through a couple of examples and I'll show you what I'm talking about. Here we have some popular examples of the three-term causal sequence. This is one of the classic ones. The external event, the environmental event, we see a bear. It gives rise to something certainly happening in us physiologically. What it probably gives rise to is changes in the autonomic nervous system. You see a bear, the parasympathetic nervous system shuts down and quickly the sympathetic nervous system kicks into place. And you see the external behavior running. Now, we all are comfortable with seeing this sort of a sequence, but a lot of times when we're asking people why they're engaging in behavior, they will only go so far as to describe the internal event, and then it seems that investigation stops. Take a look and see in some of these examples. We ask a person, why are you running? Because I'm afraid. Oh, now I get it. When I'm afraid, I run too. We are missing the essential feature here that it's the bear that gives rise to the feeling of fear, the physiological activity that is experienced, and to the actual behavior itself. But from a cultural standpoint, when we ask people why they behave as they do, people only come so far back as to talk about the second event, which we will come to find out is really not a critical issue in this entire sequence. Let's look at this second example. Somebody sees me yelling and swearing and they say, why are you yelling and swearing, Dr. Kupfer? And I say, because I'm angry. Oh, I get it. When I'm angry, I yell and swear too. We fail to recognize the fact that this is the real reason why I am angry and why I am yelling. If we look down the page here to other things, for example, I am crying not because I'm depressed, but because the death of a loved one. My father, my mother, somebody close to me passed away. It gives rise to clearly internal feelings that I have come to label as depression, but it also gives rise to crying. But depression doesn't cause the crying. This event does. In the same way that sometimes when people see marriage and go to a wedding, they also cry. And interestingly enough, a lot of their verbal behavior changes as well, even though crying is crying is crying. They describe this was a joy and happiness, this one is depression. But what's really happening here is we are actually looking at different events which give rise to different descriptions and behavior. We must always come back to the event to fully describe the behavior. Okay? Finally, we could look at something here that I am going to the dentist, and somebody says, why are you going to the dentist? I have a toothache. Well, the toothache does not give rise to you going to the dentist. The fact is that in the presence of an inflamed tooth, going to this person is resulting in the removal of pain. That's why, in the presence of this stimulus, you do this. We usually, when we have a toothache, don't go to, for example, McDonald's, or to Safeway, or to a car mechanic. We could, but our behavior is never really reinforced. So, we really go to a dentist specifically because our culture and our past, and our parents who have taken us to the dentist to have our teeth looked at, that is the proper to the dentist because you're in pain. All right. Well, we could accept this three-term causal sequence here as three terms if we could accept one simple fact, and that refers to this set of sequences. We must be able to describe how a physical event gives rise to a non-physical event, which in turn gives rise to a physical event. Consider this as a possibility. A lot of times we may look at something like a physical event, the bear. It gives rise to something which is non-physical, and a lot of people may actually not even refer to the physiological underpinnings of fear, but to something abstract called fear and anger and thinking and depression and so forth. So how does the bear give rise to fear, which gives rise to running? Okay, how does that all take place? Keeping in mind here that when we talk about the physical event of a bear giving rise to neuroanatomy changes in the autonomic nervous system, that's not a non-physical event. That is a physical event. And we are much better off talking about the bear giving rise to changes in physiological activity. And amongst the physiological things that we do, including our heart rate going up and our heart racing and all of the things that happen when we are undergoing a change in our autonomic nervous system, we also do things like run, get away from certain events, and so forth and so on. We're going from a physical event to a physical event. We are omitting this step of the non-physical event. Okay? So in that sense, it is a useful advance in this process of doing this. We can simply not go from a physical event to a non-physical event and then to another physical event and use something that is very imprecise, such as a cartoon or an animation, which simply describes what we believe might be happening here, but we have no physical evidence of this. What we are doing, therefore, is following what the natural sciences have followed for years, the law of parsimony. And we could summarize the law of parsimony as follows. The law of parsimony involves, number one, the completest presentation of the facts. That is, describe only what we see in objective, measurable terms. Two, using the least possible terms to describe the events that we actually see. Let's stop for a moment and go back to this picture. We have a three-term causal sequence. We see a bear. We feel this thing called fear, an internal structure, and we run. If we are only to use two terms here and say fear makes us run, we don't have a complete explanation because we don't know how it is that this thing called fear gives rise to running and what it is that we are afraid of in the first place. If we want to go from three terms to two terms, we simply cannot use the two terms. On the other hand, if we were to use the two terms, we see a bear and we run, you do have an account. Why you're running? You turn around and you point to the bear. Somebody sees you running, you turn around, you point to the bear, and you say, "That's why." You could also say, "You see me running? The bear is making me run. The bear is giving rise to changes in my neuroanatomy. Therefore, the bear gives rise to everything that's involved in running." And therefore, we don't really lose much when we omit this internal link, which doesn't add anything to the account. Why are you yelling and swearing? I locked my keys in the car. Why are you crying? Because my father passed away. Why are you so restless? I have an exam tomorrow morning, and so forth and so on. In other words, when we explore the three-term causal sequence and we omit every one of these words in yellow, we have a complete account of the behavior. Okay? That certainly is in keeping with this notion of using the least possible terms. And it also keeps in notion here that we should rely on observable events rather than using unobservable events. It is much better to use observable events than to go ahead and simply create a cartoon to do the work for us. That is, we can't really allow Walt Disney to replace scientific methodology. Fourth, when we have a database that is supported by, or a theory that's supported by a variety of databases, that's a lot better than simply having one theory that has one database to support it. For example, if we were to look at the origin of our kind, of our species, we could point to many of the sciences that describe the history of the planet going back, well, let's say, for example, to the time of 4.5 million years ago when our kind first started to develop, the humanoid species. And when we look at that, we could certainly point to not only things happening in terms of anatomy, we could certainly look at the paleontology, we could use carbon dating techniques and many of the other dating techniques that are used. We certainly rely on geology at the time. We could look at a whole host of other things that point to the same theory of where we might have actually started our roots as a human species. If we were only to use one of those databases and we find out that that one database is wrong, let's say, for example, the carbon dating technique, which, by the way, doesn't work really well for 4.5 million years ago, but if we were going to use carbon dating technique and we find out, for example, that it doesn't really go quite back as far as 4.5 million years ago, but that's okay, because we can't use carbon dating to date bones that were found or fossils that were found 4.5 million years ago, but we have a whole lot of other things that we can use. There are other types of dating techniques, potassium-argon series, for example. We also can rely on things in geology, such as the law of superposition, and we are able to certainly understand what happened geologically at that particular time. We have physics and chemistry that we could also rely on at that time as well. So any one of these sciences can simply replace the one that didn't work. If all we had to support our notion of the origin of humanoids was carbon dating technique, and we find that doesn't work, boy, are we in big trouble, and so was the theory. Okay? Luckily, we have many theories that support those facts. Finally, we want to find a theory which provides the greatest generality. That is, what could explain the most amount of the facts with the least possible terms. And what we seem to see here is that rather than talking a three-term contingency, what we seem to have happen is that environmental events occur that interact with our history and our unique genetic endowment, which gives rise to not only public behavior that we see people do, but private behavior that is essentially our own reaction to our own private stimulation of our bodies that nobody sees. In other words, the environment gives rise to both of these. It doesn't give rise necessarily to this one and then that one. Sometimes public behavior occurs before private behavior. Sometimes private behavior occurs before public behavior. But we're on safe ground in noting that the environment has influential control over both of these sets of behaviors. So when we talk about behavior, we usually refer to behavior as being a function of three important variables. First, genetic endowment. And there is absolutely no question how important genetic endowment is in determining human behavior and all behavior. Okay, we certainly understand this. We know more today about genetic endowment and the influences of genetics than we ever have before. We also point to the fact that environmental history is very important. And here we share in common not only the history of environmental events described by Skinner and his colleagues, but we could also point to some of the early theorists in psychology, such as Freud, who was very emphatic about the importance of environmental history in the early stages of childhood development, which determined the behavior of the adult. We certainly know environmental history is very important. We also have and are starting to gather a great deal of scientific data regarding the influence of both genetic and environmental influences on behavior, what has now come to be called gene-environment interactions. A great deal of exciting research on this entire area. And it shows that, again, that the science of behavior is starting to merge with some of the more traditional natural sciences, such as genetics and biology. Finally, the current environmental conditions. What is happening here and now that currently influences the behavior of the individuals? And when we look at all three of these things, all of them are extremely important in determining behavior. What we usually have access to as applied behavior analysts are current environmental conditions, and hopefully some degree of environmental history through the self-report of the individual, clinical records, psychosocial reports, and anything you could get your hands on that might give you an understanding of what sort of contingencies of reinforcement might have been influential in this person's life in the past, and how does that influence the current environmental conditions affecting them today. And I'm going to end on this particular note because this is a cartoon that I think appears in just about every single behavior analysis textbook that I've ever seen. And it shows here two rats conversing with each other. One is pressing the operant lever here, and rat number one says to rat number two, "Boy, have I got this guy conditioned. Every time I press the bar down, he drops in a piece of food." The idea here is that it points to the reciprocal control of behavior. The scientist is on the outside of the operant chamber, controlling the conditions for the lever to get food. However, everything that the rat does in the chamber has a direct influence on the behavior of the scientist. And the scientist, in turn, will change their scientific behavior to gather more information about their subject matter, and so forth and so on. In other words, what this cartoon refers to is the reciprocal nature of the control of behavior. Like it or not, behavior is controlled. We could use many different words to describe this control. We could call it management, we could call it influence, friendly persuasion, good advice, sound advice, a hot tip. All of these things basically refer to ways in which behavior is controlled either conspicuously or inconspicuously. Now, I won't get into exact detail about this because I believe that Skinner has done a marvelous job in the book Beyond Freedom and Dignity, and he explores all of the conditions under which our culture has used the conspicuous control in nature and inconspicuous control over behavior to support the notion of free will and so on. Well, I'm going to unfreeze myself here and get back to you and let you know that session 1 is over. Thank you very much for joining me for session 1, and I hope you'll come back and join me soon for session number 2, in which